This is Venezuela, a small South American country with over 300 million tons of oil hidden underground. Something Donald Trump covets.
We have the greatest oil companies in the world going and invest billions and billions of dollars.
But that treasure is only a number on paper if it cannot be extracted and transported to the United States, where it becomes powerful US dollars. That is why, alongside drilling operations, Venezuela has had to build massive cross-country steel pipelines to move oil from deep underground all the way to the US. These steel pipelines operate like a man-made river, carrying crude oil through thousands of kilometers from the heart of the Orinoco Belt to coastal ports. So, are you curious how Venezuela's steel river of oil is built and how it works? Let's explore it together with Mandarin Tech. Venezuela has the largest crude oil reserves in the world, mostly located in the Orinoco Belt, about 303 billion barrels, making up nearly 17% of global reserves. However, most of this oil is extra heavy crude. It is very thick and high in sulfur, and it can only be processed by highly advanced refining systems, mainly found in the United States, to become usable commercial fuel. So even with huge reserves, extraction and transportation are complex and expensive. For decades, Venezuela's oil industry has been in decline. Because oil is difficult to process, they have to transport it to the US, and the solution is the construction of giant steel pipelines to carry it. These pipeline networks carry heavy crude from deep inland areas to northern coastal ports, where it is loaded onto tankers and shipped across the ocean to specialized refineries in the United States. This constant and silent journey has created what can be called an invisible steel river of oil that sustains Venezuela's economy. The initial phase of constructing a transnational oil pipeline centers on manufacturing the pipeline segments themselves. These pipes are typically produced from high-strength carbon steel, similar to the materials used across major crude oil transport networks, enabling them to withstand continuous high-pressure flow, mechanical stress during underground installation, and the extreme temperature variations encountered in harsh environments. The first step is to shape the steel blanks into form. Rectangular steel sheets are first cut to precisely calculated sizes, chosen so the plates can be formed into cylindrical sections with a finished diameter of roughly 1.8 meters and a wall thickness of close to 25 millimeters. The plates are then sent into a multi-axis rolling system, where a series of rollers applies controlled pressure, gradually bending the steel in successive stages until both edges align and meet. At this point, a pipe shell is formed and prepared for longitudinal welding. Once the weld is fully completed, the pipe moves onward through the production line and passes through a straight-flow water cooling system to reduce the temperature of the welded seam. Next, the steel pipes are polished along every edge and corner to eliminate sharp residues and guarantee dimensional accuracy prior to additional welding. Both ends of every pipe are subsequently prepared with chamfered weld edges, forming ideal contact surfaces for connecting joints. Each pipe segment is usually around 12 meters long enough to minimize the overall number of welds while still staying practical for transport. This configuration enables the pipes to be connected rapidly, maintain leak-free pressure seals, and stay structurally sound over the long term when installed across pipeline corridors. Once fabrication is finished, the steel pipes are transferred to an open-air storage yard, where they are organized in batches and clearly labeled for logistics control and tracking. From this point, the pipes are lifted onto specialized transport vehicles using cranes or forklifts and firmly secured to avoid deformation during transportation. The pipe sections are then hauled over hundreds of kilometers to the project site, where they are welded together directly along the cross-country pipeline alignment. The installation process begins at large staging yards positioned along Venezuela's oil pipeline routes, where fully manufactured steel pipe sections are grouped by diameter, length, and planned installation sequence. At these locations, engineering teams carry out final visual inspections, carefully checking pipe straightness, corrosion-resistant coating condition, and identification markings used for logistics control. Proper organization within the staging areas is essential to maintain a continuous construction workflow, minimize delays, and reduce operational errors when installing oil pipelines across remote regions and challenging environmental conditions in Venezuela. Before trench excavation work, the building area has to be cleared and graded so heavy equipment can move without obstruction. Temporary service roads are built alongside the pipeline to support trucks, excavators, welding crews, and material hauling vehicles across the desert. Site preparation additionally covers dust suppression and sand stabilization actions to maintain clear sightlines and worker protection. This forms a critical stage keeping operations smooth throughout the entire construction project. After the route has been confirmed, heavy tracked excavators start cutting the trench along the surveyed alignment. The excavation is carried out to exact width and depth specifications, providing sufficient clearance for pipe laying and later backfilling. Soil removed from the trench is separated on site, with suitable material kept for reuse, while unsuitable earth is hauled away. Keeping trench depth and alignment consistent is critical to avoid pipe distortion or alignment issues once the pipeline is installed. In addition, along selected sections of the pipeline that pass through steep and rugged mountain terrain, blasting techniques are used to cut trenches directly into solid rock. Carefully controlled charges are positioned and detonated in sequence to break apart the bedrock along the planned alignment. The blasted trench that results provides sufficient depth and width to securely seat the pipeline, even in locations where mechanical excavation cannot operate. Following excavation, the pipe is never set straight onto the trench base. Instead, a layer of carefully selected fill, usually fine sand or screened soil, is evenly placed along the bottom to form a support bed. This layer spreads loads evenly and limits stress buildup on the pipe. The bedding is leveled and gently compacted to reach the specified elevation. In desert environments with loose, dry soils, this step is vital for stability. To build large diameter pipeline corridors, a construction zone roughly 40 meters wide is prepared ahead of time, enabling the full installation sequence to move forward without interruption at an average rate of about 1.5 kilometers per day. Pipe segments approximately 18 meters long are chosen to limit the total number of field welds, while at the same time placing very high demands on lifting operations, transport logistics, and precise alignment during construction. At the welding station, a hydraulic internal lineup clamp is inserted inside the pipe joint and expanded using 360-degree gripping shoes, holding both pipe sections perfectly concentric and accurately aligned before and throughout the root pass. An automated welding system, supported by a workforce of around 80 people and dozens of specialized machines, is then deployed and is capable of completing up to 150 welds per day on 42-inch diameter pipes. After welding is completed, each joint is subjected to automated ultrasonic testing to verify the absence of internal flaws. The field joint coating team then carries out abrasive blasting to prepare the surface and applies a multi-component liquid epoxy coating, creating a durable, fully sealed protective layer before the pipes are finally lowered into the trench and backfilled. The connected pipe sections are set down into the trench using side boom tractors, which are specialized tracked machines built specifically for installing large diameter pipelines. Several side booms work in sequence along the route, each lifting part of the pipe string with padded slings and steel cables to protect the external coating. The pipe string is lifted evenly and kept suspended above the ground while the machines advance slowly beside the trench. Close coordination between operators is critical to avoid twisting, bending, or unwanted contact with the trench walls. Once proper alignment is achieved, the pipe is lowered gradually, centimeter by centimeter, until it settles at the center of the trench on the prepared bedding. Throughout the operation, surveyors continuously check pipe elevation, straightness, and natural curvature to ensure no residual stress is introduced. This approach enables fast, controlled, and highly precise placement, making it well-suited for long, straight pipeline routes across flat desert terrain. In certain sections where the terrain becomes steep or hazardous, the pipe laying process follows the same principles, but requires additional precautions. Specialized lifting equipment, reduced installation speeds, and shorter pipe strings are often used to maintain control on uneven ground. Extra anchoring and alignment checks are carried out to prevent pipe movement or excessive stress. These adaptations allow construction to continue safely, even in the most challenging landscapes. Once the pipe has been set in place, the trench is refilled in several stages. The first layer uses fine-grained material to shield the pipe coating, followed by the soil that was originally excavated. Each layer is compacted using mechanical equipment to reach the specified density and limit future settlement. In desert environments where soil behavior is influenced by wind and extreme temperature changes, effective compaction is essential for long-term pipeline durability. Once extracted, crude oil is transported directly from the production fields to coastal export terminals through the massive pipeline network that has just been installed. From these ports, the oil begins a months-long journey across the ocean aboard large tankers, moving steadily toward its final destination. Eventually, the crude arrives at some of the most advanced refineries in the United States, where it enters a new phase of its journey. Inside these facilities, complex refining processes take over, transforming raw crude oil into the fuels and products that power modern economies. Once crude oil arrives at a refinery, it begins its transformation into gasoline through the most critical stage known as fractional distillation, a process that separates crude oil into different fuels based on their boiling points. The crude is first heated in a furnace to roughly 650–670 degrees Fahrenheit, causing the mixture to vaporize before being directed into a massive fractionating column that rises several stories high. Inside the tower, dozens of trays are positioned at varying heights, each held at a specific temperature, allowing lighter hydrocarbons to rise while heavier fractions condense lower down where temperatures remain highest. Lubricating oils and heavy residues settle near the base, diesel forms above them, kerosene collects higher still, and in the middle of the column, gasoline vapors condense within a boiling range of about 90 to 220 degrees Fahrenheit. At the very top, light gases such as methane, propane, and butane are separated. However, the gasoline obtained at this stage is not yet suitable for engines and must undergo further refining steps, including catalytic cracking to split heavy molecules, reforming to increase octane levels, and blending with additives to meet modern standards for clean combustion, anti-knock performance, and reduced emissions. Finally, the finished gasoline is stored in large tanks before being transported by pipelines, rail cars, or tanker trucks to fueling stations, completing the journey that turns dark, viscous crude oil into a clear, volatile fuel capable of powering billions of vehicles worldwide. Now let's go back a bit to the oil extraction process. Oil can be extracted from the sea or from land, but in Venezuela they mainly extract it from land. The process is far more complex and costly as you imagine. The first step is still geological surveying and exploration. Engineers use seismic waves, exploratory drilling, and rock sample analysis to identify shale formations with sufficient porosity and permeability to hold oil and gas. Once a promising site is confirmed, the drill bit does not simply go straight downward, it is steered horizontally deep underground. These horizontal wells can extend for thousands of meters, greatly increasing contact with the reservoir. But to truly unlock the hydrocarbons trapped inside the rock, hydraulic fracturing, or fracking, is employed. Millions of liters of water mixed with sand and chemicals are pumped down at pressures that can exceed 10,000 psi. This immense force creates countless microfractures with sand grains propping them open to allow oil and gas to flow out. As hydrocarbons begin to move, they are channeled upward through production tubing. What reaches the surface, however, is not pure oil, but a mixture of crude, natural gas, water, and sediments. At the well site, this stream passes through multi-stage separators. Oil is collected in temporary tanks, gas is compressed and sent into pipelines, and water is chemically treated before being reused or discharged. This process has delivered enormous output, helping the United States become the world's largest oil producer. But the costs are equally staggering. Each well consumes tens of millions of dollars and vast amounts of water, and any mistake in drilling or cementing can lead to chemical leaks, groundwater contamination, or even land subsidence. So now you've explored the entire process of transporting oil through Venezuela's massive pipeline network. It is this very river of oil made of steel that has connected remote regions to modern refining hubs, keeping the global economic machine running. Will Donald Trump bring changes to the flow of oil in Venezuela? Stay tuned to find out. See you in the next videos.